Hello, my name is Mark Schippenmuller. I'm the product manager for the Alexa LF, and as part of this video series, I will introduce you to some of the features of the Alexa LF. First of all, we went through great lengths to make sure that the Alexa LF is compatible with almost all the accessories we already have for the existing Alexa cameras. So it works with the existing Alexa viewfinder, the accessories, the wireless system, the existing lenses, the workflow, the Pro accessories, our electronic control system, and our Arri camera stabilizer system. Now, in detail, let's talk first about the wireless. We have integrated 3 radios into this camera, and they don't interfere with each other. So all 3 radios can be operated at the same time without interference. First, we have 2 Wi-Fi antennas here for the Wi-Fi radio. Then there are 2 wireless video antennas that can send a signal to our Arri wireless video receiver. And then we have 1 antenna here for wireless lens and camera control, something like the WCU4. Next, we have, as we have in the SXT, we have in the Alexa LF 4 independent monitoring outputs. First, there is the viewfinder. Everything in the viewfinder can be set independently from the 3 monitor outs that we have on the other side here. Monitor out 1, 2, and 3 that can be set independently. All the 3 mon outs can do SDR or high dynamic range outputs. And the top 2 here, monitor out 1 and 2, can also do a 6G output, which gives you 4K UHD at up to 30 frames a second. The user interface of this camera is exactly the same as on all the other Alexas, so there's really no learning curve when you're starting out with this camera. And we can do fast sensor mode switching. On the older Alexas, it takes a while to switch the sensor mode, and then you have to reboot and do a factory reset. I'm very sorry. On this camera here, there's no reboot, no factory reset. It takes 20 seconds, you're in a new sensor mode. Now, for anamorphic monitoring, we have 4 different options. So in the anamorphic monitoring menu, I can actually set the camera to de-squeeze by a factor of 1.25, 1.3, 1.5, or 2. So whatever anamorphic lens you have out there, the Alexa LF will work perfectly with that anamorphic lens. We've also increased the number of accessory power outputs. I'm always being told by the rentals there are never enough accessory power outputs on the camera. So right here used to be a connector called LDDFP for a device we don't actually sell anymore. And we changed that into a 24-volt accessory power output. On this camera, we now have 4 24-volt accessory power outputs, 2 in the back here, and then 2 in the front, and we have 1 12-volt power output in the front. This camera is the same robust, reliable product quality as all the other cameras, and it has a temperature range from -20 to +45 degrees Celsius. That is -4 to +113 degrees Fahrenheit, and that is worth mentioning because I think our cameras are the only ones that have that large of a temperature range. Last but not least, let's talk about onboard batteries. This camera is not compatible with the existing 12-volt battery adapters, but we are offering 2 other adapters. The first one makes the camera compatible with the Hawkwood's 26-volt real power onboard batteries. They provide 26 volts, which makes the camera very happy. And the second one is compatible with the Bebob high-load 14.4-volt onboard batteries, and the adapter actually has a voltage booster inside that boosts the 14.4-volt up to 20 volts, which is the minimum that the camera will accept. Let's do a little recap. The Alexa LF is very similar in features to the Alexa SXT-W, including the Arri wireless video system. You can do anamorphic monitoring in the viewfinder and on the mon out. We have more power outputs, and the camera has the same user interface, same reliability, and same global support as all the other Alexa cameras. Thank you very much. Hello, my name is Mark Schippenmuller. I'm the product manager for the Alexa LF at Arri. And as part of this video series, I will be talking a little bit about the Alexa LF sensor. Now, there are 2 reasons why we developed the Alexa LF camera. First, there's a trend towards full-frame lenses and full-frame cameras. And second, the Alexa 65 was a huge success, which told us there's a demand for large format cameras. Now, the Alexa 65 is a rental-only product, and not everybody needs the really large sensor of the Alexa 65, which is why we developed the Alexa LF, which is indeed a sales product. So let's look at the sensors, and we're starting with the Alexa 65 sensor. So this is the really, really large sensor, Alexa 65, 3 times as big as a regular Alexa Super 35 sensor. In comparison, this is the size of the Alexa LF sensor. This is 4448 by 3096 photo sites. So yes, this is a 4K sensor, and it uses the same photo sites as the regular Super 35 Alexa. So the same size and the same type of photo sites. It also uses the same color science. Now, this sensor is 36.7 by 25.54 millimeters large, which means it's actually larger than full frame, which is why we're calling it not a full frame camera, but a large format camera. And that's how the name Alexa LF came about. So here's a picture of the Alexa LF sensor, and this sensor can be operated in one of 3 modes. Now, the good news is all 3 modes have been approved by Netflix, and Netflix has also approved recording Arri RAW or ProRes in 3 of the 4 flavors with this camera. But let's look at the 3 sensor modes. Here's the first sensor mode, LF Open Gate. That is the maximum image area and the maximum resolution you can get from this camera. It's 4448 by 3096 pixels, and you don't have any surround view because there's nothing around it anymore. You record everything the sensor sees. In order to cover this sensor area, you need a full frame lens, and the maximum speed is an amazing 90 frames a second on this sensor mode. Here comes the second sensor mode. This is LF 2.39 to 1. This is 4448 by 1856 pixels, and that's what you would use if you want to shoot widescreen with full frame spherical lenses. Now, this also doesn't have any surround view because we want to record the fewest number of photo sites in order to achieve the highest speed. This sensor mode runs up to 150 frames a second in order to do slow motion. And the third sensor mode is really the most interesting one. It's called LF 16 by 9. This is the smallest image area that still is considered 4K by Netflix. So it's 3840 by 2160 photo sites. That's 4K UHD. It does have surround view. That's the dotted line, indicates the surround view. And of course, full frame lenses cover this, but some Super 35 lenses can also cover the sensor mode, which makes it really, really interesting. Now, you may ask, how does that actually work? If you look at a lens, and if you look at the image a lens projects, most lenses project a circle. That's what this looks like. Now, inside of that circle is the so-called image circle. That is the area within which the lens manufacturer guarantees the image quality of the lens. But outside of the image circle, there is still light. This is the so-called illumination circle. We found that the illumination circle of the ultra primes, starting from 20 millimeters on and longer, cover the LF 16 by 9 sensor mode. Also, the master primes, starting from 35 millimeters and longer, cover the LF 16 by 9 sensor mode. And in fact, there's a whole bunch of other Arri lenses that cover LF 16 by 9. So if you're doing a television series and you can't afford full frame lenses, even though of course you should be shooting with the signature primes, you could still use Super 35 lenses to shoot your television series with the Alexa LF camera. Now, how do you find out which lens covers which sensor mode? There's an online tool called the Arri Lens Illumination Guide that you can find on our website, and that allows you to choose a camera, choose a lens, choose a t-stop, a focus setting, and then you actually see how much a given lens covers. And I spent a very enjoyable weekend with the Lens Illumination Guide, just playing around there, and I found that the ultra primes, starting from 20 millimeters on and longer, actually cover the LF 16 by 9 sensor area. Also, the master primes, starting from 35 millimeter and longer, cover the LF 16 by 9 sensor area. So here's a list of all the Arri lenses that cover the LF 16 by 9 sensor mode. Of course, you should shoot your own tests, try other lenses, see what you find. Now, what if you want to shoot with a PL Super 35 lens on this camera, on the Alexa LF, and match a Super 35 Alexa? Well, there are 2 ways to go. If you're shooting with anamorphic Super 35 lenses, you can set the camera to LF 16 by 9 sensor mode, which is 3840 by 2160, and that is exactly the same height as the Super 35 6 by 5 sensor mode. That's the sensor mode you would use on a Super 35 Alexa for anamorphic lenses. So all you need to do then in post, crop off the edges of the image, and you have the same image that you would have if you shot with a Super 35 Alexa. Now, if you're shooting with spherical lenses, one of the ways you could go is use the LF 2.39 to 1 sensor mode. That has the advantage you can go up to 150 frames a second, and it is almost the same height as the Super 35 3.2K sensor mode. Now, LF 2.39 to 1 is 1856 photosites high, and the 3.2K is 1800 photosites high. So it's almost the same. And again, you chop off the sides, you have the same result. That is it. Here's a brief recap now. So the LF sensor is slightly larger than full frame. It can be operated in one of 3 sensor modes. You can use some Super 35 lenses for a 4K show in LF 16:9 sensor mode. To find out which lens covers which sensor mode, use the online lens illumination guide. And all 3 sensor modes, as well as Arri RAW and ProRes recording, are Netflix compatible. Thank you very much. Hello, my name is Mark Schipper-Mueller. I'm the product manager for the Alexa LF. And as part of this video series, I will be talking about the large format image now. So let's start with the sensor. This is the Alexa LF sensor here. It is twice the size of a Super 35 sensor, but it uses the same photo sites, same type and same size as all the other Alexas. And that means you get the same best overall image quality that you've gotten with the other Alexas. Best overall image quality means high dynamic range, wide color gamut, true 800 ASA sensitivity. It means a low noise level and great skin tones. But there are some things you get in addition when you shoot with a large format sensor. First of all, you actually get less noise, even less noise than the regular Alexa has. And here's the reason: you have more photo sites. Now, the noise per photo site is the same, but because we have more of them, the noise actually becomes smaller. I've talked to a number of cameramen who are shooting with the Alexa LF right now who are saying that they consider the 1600 ASA of the Alexa LF similar to 800 ASA on an Alexa SXT or Alexa Mini. In addition, you have a better noise reduction. Now, noise reduction on this camera is off by default, but you can turn it on. And when you turn it on, you get something called enhanced motion detection. And what happens there is the camera checks all the pixels around every pixel, and that helps you to avoid artifacts, noise reduction artifacts in high motion areas. When you record ProRes, the noise reduction is baked into the image. When you record Arri RAW, noise reduction is just recorded as metadata, so it's not actually in the image. On top of that, we have an improved stray light management. We noticed when we actually shoot with this camera that a lot of light from the lens bounces around in the lens cavity here, which reduces the contrast. And we don't want that. We want to make sure we get all the contrast from the lens straight to the sensor. So we actually made, I think it was 7 different types of prototypes of light traps, light baffles here. We tested each one of them, and the best one actually went into this camera. So now you can get the best contrast from the lens actually all the way to the sensor. Now, shooting with a large format sensor, it's a larger sensor, and this has some consequences. And it's a little difficult, but hang on with me here. If you want the same angle of view on a large format camera as on Super 35, and you have the same t-stop, same shutter angle, same ASA, and the same distance to your subject, you have to use a longer focal length. Now, the factor there is about 1.5, so to get the same angle of view on a 50mm for Super 35, you have to use a 75mm for a large format. Now, using a longer focal length lens means you get a shallower depth of field. This means a greater separation between the image and the background, but it also means a visual compression. This is something that works especially good on faces. It makes faces look better, and it makes items in the frame appear closer to each other. The smaller your sensor is, the more far apart everything seems to be. Now, by playing with these parameters, with the focal length, the t-stop, the shutter angle, ASA setting, and the distance, you can get various different image expressions. For instance, you could do a wide shot with an out-of-focus background, or you can go closer to your subject without the distortion you normally get from wide-angle lenses. This is really now up to you guys. You need to play around with these cameras and get some of the great images that the camera makes possible. And here's the recap. The Alexa LF has the same best overall image quality as the other Alexas. The larger sensor has less noise and a new noise reduction option. And for the same angle of view, when you use a large format camera, you get a shallower depth of field, you get a compressed perspective, and there are other creative options. That's it. Thank you very much. Hello, my name is Mark Schipper-Mueller. I'm the product manager for the Alexa LF at Arri, and I will talk a little bit about the workflow with the Alexa LF. Like the Alexa SXT and SXTW, this camera can record uncompressed, unencrypted Arri RAW or fast and efficient ProRes. Right now, you record both of those formats onto the SXR capture drives, which come in a 1 terabyte or a 2 terabyte version. And with the next software version, we should also be able to record the ProRes onto the SBS Pro Plus 256 gigabyte card. Now, this camera, like the previous cameras, also has the Arri look management. So you can create an Arri look file in pre-production, then you can do live grading on the set, and all your looks, the 3D lookup table as well as the CDL values, will get recorded in the metadata and automatically travel with the footage through post. That can lead to automated dailies, where the look gets automatically applied to the dailies. You don't have to do anything anymore, as well as to editing with looks. So the editor sees the same thing while editing that the director saw on the dailies, that the DP saw on the set. And then in final grading, one can always look at that as a reference or even use it if so desired. Now let's talk a little bit about the recording resolutions. We earlier talked about 3 sensor modes from the Alexa LF. There's LF Open Gate, LF 2.39:1, and LF 16:9. You can record each one of those in Arri RAW or ProRes in its native resolution. So LF Open Gate, that's 4.5K, Arri RAW or ProRes. LF 2.39:1, also 4.5K, because it's the same width. And then LF 16:9 can be recorded in 3840 by 2160, that's 4K UHD. For the LF 16:9 sensor mode, there's an extra option where you can do an in-camera downres either to 2K 16:9 or to HD 16:9, both in ProRes. For your workflow, we have a number of online tools available to support you on the set. And let me just go through all of those first. First, we have the Lens Illumination Guide. That is a tool that allows you to see what the lens illumination circle is for a given sensor mode. So you can go into the tool, you can choose which camera you want to look at, you can choose which lens you want to look at, you can choose the distance to the subject, the t-stop, because all of those affect the illumination circle, and then you actually see an image of the illumination circle for that sensor mode. That's very, very useful if you want to figure out which lenses do you actually want to test, which lenses cover the sensor mode that you desire for your show. We recently upgraded this tool. You can now import frame lines into this tool, which makes it even more useful. Where do those frame lines come from? They come from the Frameline Composer, another online tool that allows you to create frame lines in very, very high detail. Then you can download them to your computer, put them on an SD card, put the SD card in the camera, and then you have those frame lines right there on the camera. If the DIT needs to find out how many gigabytes of footage they will create with a given sensor mode, with a given camera, they can use the Formats and Data Rate Calculator, another online tool. And last but not least, we have the Alexa LF Simulator that is an online tool which simulates this whole display panel here, so you can get familiar with the user interface and all the menus of this camera in the comfort of your home. There are also 3 software apps that you can download to your computer. First is the Arri Color tool. That allows you to create an Arri look file to be loaded into the camera. It also allows you to import lookup tables and export lookup tables from and to Arri look files. Then we have the Arri RAW converter. It takes Arri RAW footage, you can view it, it's a viewer, and then you can convert this footage to other file formats. And the last tool we have is called the Arri Meta Extract. You can upload Arri RAW or ProRes footage into this tool, and it'll extract the metadata and output it as a separate file. Those are the Arri tools, but we're also distributing our image science as well as our metadata information to third parties so they can put it into their tools. And I'm very happy to say that almost all third-party workflow tools by now support the Alexa LF. So if you come into your post house and you say, I got an SXR capture drive full of Arri RAW, they know what to do. They can process it just like they process the Arri RAW from the SXT camera or the previous cameras. And the last thing I want to talk about briefly are the lens metadata. With this camera, we're introducing a new lens metadata system called LDS2. You can see here on the LPL lens mount, there are 4 contacts for the LDS2 lens metadata. The signature primes can provide this information to the lens mount, which then communicates it to the camera. We're also licensing the LDS2 lens metadata to other lens and camera manufacturers, so you'll see other lenses and other cameras have this system. What's different about the system is that we have now absolute encoders in the lens. If you recall on the LDS1, you put the lens on the camera and then you had to actually turn the rings in order for the camera to recognize that there is an LDS. With the LDS2, you put the lens on the camera and the camera immediately knows the position of each of the 3 rings. Also, we have a much higher precision and a much higher data rate in LDS2, so at high frames a second, we can still get very accurate lens data information. The whole thing is network capable, so we could theoretically have the lens talk to an adapter, the adapter talk to the camera, that's for future products, and it is compatible with the Cook/I metadata system. Now for the older lenses, the PL-mount lenses, we also have something. The PL-to-LPL adapter is fully capable of talking either LDS1 or Cook/I. These can be mounted either so the contacts are in the 12 o'clock position or so the contacts are in the 3 o'clock position. This adapter supports the LDS1 lens data system as well as Cook/I, and that pretty much covers all the lens data systems out there. That's it for the workflow. A brief recap. The Alexa LF can record Arri RAW and ProRes, currently onto SXR capture drives, and later also on SBS Pro Plus cards. You can record at native resolution, or you can have it down-res to HD or 2K, and there's a full line of free online tools available from Arri, but we also provide information to third parties, so third-party tools also support this camera. And last, the system can record Arri LDS1, Arri LDS2, or Cook/I. And that's it for the workflow session. Thank you very much. Bye-bye. Hello, my name is Mark Schöpping-Müller. I'm the product manager for the Alexa LF at Arri. And as part of this video series, I will introduce you to the LPL lens mount and the PL-to-LPL adapter. Alexa LF is part of a complete large format system consisting of the Arri signature prime lenses, the new LPL lens mount, and the Alexa LF camera, and last but not least, the PL-to-LPL adapter. When we started thinking about the signature prime lenses, we asked our optical designers what is the ideal lens mount for a full-frame lens. And they told us that the PL lens mount is actually not ideal, because the diameter of the PL lens mount, the 54 millimeters, was designed for a Super 35 image. Large frame, of course, has a larger image. Also, the flange focal depth, that is the distance between this flange and the film plane, was designed for film cameras when we still had mirror shutters. So the distance actually is longer than is ideal for optics design. So what is the ideal lens mount for a full-frame lens? Well, we've implemented it with the LPL lens mount. It's a larger diameter, this is a 64 millimeter diameter, and it's a shorter flange focal depth, that's a 44 millimeter flange focal depth. This allows us, and really anybody else who makes lenses with an LPL lens mount, to make lenses that are smaller and lighter, with a faster T-stop, and at the same time with better image quality and a more pleasing bokeh, which is something we always strive for. The combination of all those features would not be possible with a PL lens mount, which is why we went to the LPL lens mount. Now, those are the dimensions of the LPL lens mount. The actual mechanics are very similar to the PL lens mount. We actually had a number of different types of designs that we looked at, some very interesting, but we felt that most of them ended up being too complicated, and we wanted something very robust, very reliable, and the PL lens mount mechanics are robust, they're proven, they're reliable, so that's what's being used here. Now, when we designed this, we thought long and hard about compatibility, because we know not everybody is going to use these lenses in the beginning, not everybody's going to want to use LPL lenses, and people may also want to use other cameras. So we came up with the following system. First, we have the signature primes that attach to an LPL lens mount attached to an Alexa LF camera. Now, anybody who uses that will probably also want to use another Alexa. So that same LPL lens mount also works with regular Alexa Classics, XTs, and SXTs. A second LPL lens mount can be attached to the Alexa Mini or the Amira, and then a third lens mount is designed specifically for the Alexa 65. So we also are licensing this lens mount to other camera manufacturers, so you can use signature prime lenses on other cameras as well. That's it on the camera side. Now let's look at the lens side. We talked with Arri Rental, and they're now changing all their 65 format lenses to LPL mount, and we're also licensing the LPL mount to other lens manufacturers. So you will start seeing lenses from other lens manufacturers with the LPL lens mount. But we do know that people also want to use PL mount lenses, so there is the before mentioned adapter, the PL-to-LPL adapter. This adapter works with PL-mount Super 35 and PL-mount full-frame lenses. It allows you to quickly switch on the set between a PL-mount lens and an LPL-mount lens, and it sits very securely in the LPL-mount. Because this is so important, we decided to ship one with every camera that we're shipping out. So that's it for the LPL lens mount and the PL-to-LPL adapter. A little recap. The LPL lens mount is the ideal lens mount for full-frame lenses. We're licensing it to other lens and other camera manufacturers, and the use of PL lenses is still possible with the PL-to-LPL adapter. That's it. Thank you very much.